Hello everyone. Previously we had discussed on the topic Fenwick tree, right? So we have already discussed on the Fenwick tree and the segment tree previously. Now the last topic in the playlist will be about the sparse table, right? So let's try to understand the sparse table, right? So let's get into the definition part first. A sparse table is a data structure used for answering static range queries like min or max, right? So this sentence itself is very important. A sparse table is a data structure used for answering static range queries, usually range minimum queries, right? So RMQs, right? So a sparse table is a data structure used for answering static range queries like min or max in big of 1 after big of n log n pre-processing, right? After big of n log n pre-processing. So this one, just keep this in mind. This is very important. Answering static range queries in big of 1 after big of n log n pre-processing, right? So this is the reason we'll be making use of the sparse table. So whenever there is no requirement of the updation, see, usually in the Fenwick tree we will be solving whenever there is updation required, and usually in the segment tree as well we have not went with this one update, but usually when we can go with the update as well. So the problems that can be solvable by the segment tree when there is no updation, so in that case that particular problem can be solved by sparse table as well. So the syntax will be not the syntax, basically the length of the problem will be little bit this one small comparatively with a segment tree, right? So they sparse table is faster to code than segment trees, just remember this one, right? So that is the reason we can just go with a sparse table instead of the segment tree whenever there is no updation required. Whenever I'm strictly telling, whenever there is no updation required, we will be going with a sparse table, right? So we can go with a segment tree as well, as segment tree will be lengthy and complex, so it's better we can just go with a sparse table, right? Again, what is sparse table here? A sparse table is a data structure used for answering static range queries like min or max and big of 1 after big of n log n pre-processing. Just keep this in mind, right? It pre-computes, so this is one of the important points as well. Just remember, just try to remember this. It pre-computes answer for overlapping ranges of power of 2 lengths. We'll be going with the log 2. Just remember this one, 2 to the power of j something will be there. So I'll explain that one while we write the code or while we take the example, right? So just remember this one. It pre-computes answer for overlapping ranges of power of 2 lengths and uses them to answer queries without recalculating. This is important. It pre-computes answers for overlapping ranges of power of 2 lengths and uses them to answer queries without recalculating. This is very important, right? So this is the definition part and the important points of the sparse table, right? So we are done with the sparse table part, definition and the important points part. Let's get into the example part. So let me do one thing. uh, just give me a second here, 1 second. So now let me give here, so we will be making use of the math module. So I'll just give here import math, right? So I'll just go with class because we'll be going with a logarithmic too, so we'll be making use of the math module, right? So let me go with sparse table here. So this is fine. Within the sparse table, what we'll be doing, first part is always initialization, as we are going with a class sparse table, right? So I'll just go with uh, initialization. Let me remove this. Along with the self, I need array as well, right? So I need array as well. So this one, let me go with self dot n. Let me initialize this one to the length of the array, similar to the this one segment tree. Next, we have to go with a max power of 2 that is needed here. We have to go with a max power of 2 that is needed, right? So I said we'll be going with a logarithmic 2, right? So this will be self dot, let me consider log here. So let me make use of math dot floor. This is fine. Next, let me go with math dot let me go with log 2 here. This is fine. Let me go with self dot n. This is fine, plus 1. plus 1. So let me come out of this one entirely. So this one will be self dot segment tree. Sorry, sparse table st have considered. Sorry, we are going with the initialization part, right? So this one will be, just give me a second here. Yeah, this one will be self.st. So I'll just go with again initially 0. This one has to be, sorry, 0 into, we have already considered self dot n, and for let me consider for underscore in range, it has to be in the range, this one log, self dot log. So I'll just go with self dot log. We have, this is fine, we are done with this part almost. So we will be going with the build method. So after building method I can write this one. So before writing the build method itself, I'm making use of the build. Don't get confused here. I might usually I forget things. So this one always mentioning the build. So usually I'm writing this one now itself, right? So where is the build method coming from? So we haven't written the build method yet. We'll be writing in the future. Just wait for a second. So this one, self.n equals length of the array. We are just storing the length of the array here. This one, line number 12, what we are doing here, we are just going with a max power of 2. That is required, right? So this is important. So line number 13, 13, what we are doing here, this one we are going with the table for storing the minimum values. We are going with the table for storing the minimum values, and finally we are building the sparse table. So this build method, whatever I have made use of, we have not written that one yet. We'll be writing now, not to worry. So I just usually forget that one, so I wrote first itself, right? So now let's go with the method build here, right? So this one build, let me go with the self as well as array. So this is fine. Now let me do one thing within the build method. The first thing is here, we have to initialize the first row, right? So we have to initialize the first row with array elements. What we need to do, we have to initialize the first row with array elements, right? So this one, let me go with a for loop here. For I in range, this is also fine. Now I'll just go with the self dot n. This is also fine. The next step would be within the for loop, I'll just go with the self dot st. So this is fine. So this one will be 0, this one will be I. Let me initialize this one to array of I. This is fine, man, right? So now let's do one thing. Let me initialize the j to 1 as well, right? So this is fine. So let me write the while loop here, because we have to go for each power of 2, right? So we have to go for each power of 2. So first here for loop, whatever I have written, we have initialized the first row with this one array of I, right? So this is fine, we know. We have considered j equals 1 here. This is fine. Why we have to consider, because we have to go for each power of 2, right? So I can just write the while loop here. So this one I'll just make use of the this one left shift operator here, bitwise left shift operator. So this is fine. This one will be less than or equal to self dot n, less than or equal to self dot n. So this is fine. The next step would be let me initialize I to 0. Let me initialize I to 0. And again, let me go with the while condition here, or the while loop. So this one has to be while I plus, so this one less than j, not less than, basically it's left shift operator j, right? So this one less than or equal to, so here there comes the left this one less than or equal to, sorry, self dot n. This is fine. Now this, what we are doing, while I plus one left shift operator j less than or equal to self dot n I have given. So again, so we are filling the intervals of length 2 to the power of j. We have considered log 2, and now we are filling the intervals of length 2 to the power of j. So this part is very freaking important, right? So what we are doing, again, we are filling the intervals of length 2 to the power of j. So within this while loop, so we have to consider first half of the interval and the second half of the intervals both differently, right? So I'll just go with, see here, let me give you, so this one is fine, man, self dot n. Let me come, So while loop, right? So this is fine. Now let me go with self dot sparse table, nothing but st. I've considered the variable st, so this will be j, so this will be I. This is also fine. So this one will be min. Within the min, what I'm gonna do here, we have to consider first half of the interval differently and the second half of the interval differently. So let me go with the first half. This one will be self dot sparse table, nothing but st. So this one will be j minus 1 and I, j minus 1 and I. And next we have to consider second half of the interval. So this one will be self dot st. This is fine. This one will be j minus 1. Uh, Along with the j minus 1, we are going with the second half of the interval. So we have to go with I plus, right? So this one will be I plus 1 left shift operator. Finally, j minus 1. J minus 1. This is fine. So we are done with the first half and by considering the first half and second half of the interval, right? So this is fine. uh, why this one? Just give me a second. This is fine. Let me come out of this one entirely. So this one I equals I plus 1. Why we are considering this one? Because we are filling the intervals of length 2 to the power of j. First we considered first half of the interval and the second half of the intervals. Now we have to go with we have to increment, right? I equals I plus 1. Also we have to increment the j as well. So we will be going with a j equals j plus 1. Just give me a second here. 1 second. Did I miss anything? Did I miss anything? No, right? I equals I plus 1. This is fine. Finally, let me go with j equals j plus 1. This is fine, man. Now we are done with the build class. So we are done with building basically, right? So we are done with the build method. So now let me do one thing. We are left with the query method, right? So let me go with the query method. I'll just go with the def. This one will be query of, let me go with self comma left comma right. So this is fine. Within the query method, so we have to find the largest power of 2 within the range. Largest power of 2 within the range, as we have considered log 2. So we have to find the largest power of 2 within the range. So I'll just go with j equals int. So this one will be math. Where is math? Math. So this one dot log, math dot log of, I'll just go with right minus left plus 1. So we have already solved many problems using the sparse table as well, right? So in the JavaScript as well, in the Java as well. Now we are doing it in the Python as well, right? So recently we finished the playlist, this one, solving the problems on segmentary, Fenvictory, as well as the sparse table, very recently, right? So just now, day before yesterday, before 2 days back, I finished. So now I'm solving the problems on the advanced this thing, what do we call, dynamic programming, right? So by this time we have already discussed this one, the same topic, and we have seen the same thing in the JavaScript and Java as well. If you are going with this one, a different programming language, you can just check those problems as well, right? So you can just check those problems. And I have given the templates with the definition part, as well as for the understanding purpose. I have explained every single line and other stuff, and I have uploaded the same thing on my github as well, in my github, sorry, as well, right? So I can just check the repo as well. So exactly within the CP templates, and within the CP templates, right, you'll get it, right? So you can just check that one as well if you want, right? So let's move on with the further things, move on with the further steps here. Now, so we are finding the largest power of 2 within the range. So after that one, we are left with only one step, nothing but we have to return. What we need to return, we have to consider the first segment and the second segment, right? So we need to return the minimum of minimum from the first segment and the second segment, as we are dealing with a log 2 only. So I'll just go with return min of, this one will be self dot sparse table. This one will be j, and this one will be L, right? So this one will be j, this one will be L. This is fine. The next thing is self dot st. So this one will be j, and this one will be r minus 1 left shift j here. So this one plus 1. This is fine, man. So we have went with the first segment and the second segment. This is done. So let's do one thing. Let me come out of this one entirely, man. Right. So we are done with the query and the build methods. So let's test, or let's go with the example usage. So let me go with some random array. This here, I'll just go with 1, comma 3, comma 2, some random numbers here. 7, and I'll just go with 9, 11. This is fine. So this is fine. Now let me consider st here, nothing but the sparse table. So we have given sparse table class, right? Sparse table of, let's pass the array. Let's pass the array. So let me go with a print here. So this one will be sparse table dot, we have to go with the query method. I have already written the query method. This is showing in the suggestions, right? So let me go with 1 comma 4 here. So this is nothing but the original array, man. Line number 37, line number 38, man. We are just building the sparse table here, right? So finally what we are doing, so we are trying to get the minimum from index 1 to index 4, minimum from index 1 to index 4. So this is index 1, this one 1 2 3 4 until here, from 3 to 7 9. So what is the minimum from 3 to 7 9? Basically here 2, right? 2. We have to get the answer 2, quite obviously. We are trying to find the minimum from index 1 to 4. So index 1 starts from here, as it is 0 based index. Index starts from this one 0 1, this one, right? The value 3, we have at the index 1. Index 1 to index 4, this one 2 3 4. Index this one from the value 3 to value 9, basically, right? So from the value 3 to value 9, what is the least, this one minimum value we have? 2. So we have to get the output 2 here, right? So let me go with Python here. Let me go with Python, and let me right click, rename. Let me copy this one, paste it over here dot py, right? So we are getting the output 2. So we can just make use of it for the min, max, and range minimum queries, right? So usually we will be going with a range min or max, right? RMQs. Basically, we'll be going with a we'll be making use of the sparse table to solve the RMQ based problems, right? Range minimum queries or max, right? Usually. So when there is no updation required, instead of the segment tree, we can just go with a sparse table. The code will be less complex, and also, yeah, if if we want to change anything, we can change easily if we make use of the sparse table instead of the this one segment tree. If you're good with the segment tree, you can go with a segment tree as well. Most of the times I go with the segment tree, right? Segment tree also, I avoid this one as well, this one bit as well. Most of the times I avoid this one as well, right? So because I have solved more problems on the segment tree, I feel I'm good with the segment tree, so I just go with the segment tree rather than the sparse table. Sparse table is good when no updation is required, and usually it is used to solve RMQ, nothing but the range min max queries, right? So I hope this part is completely clear, man. Sparse table part is completely clear. I mean, topic sparse table is completely clear. So let's finish it off with a sparse table data structures in Python. Let's finish it off this one. Let's finish this playlist with a sparse table topic, right? So this I'll be uploading on my GitHub as well, so you can just check there as well for the code, right? And this will be on the YouTube as well, quite obviously. So you can, if you want to know step by step, you can just check my video, right? So next, I'll be from today, I'll be going with this one, fast API. I'll be learning fast API, and I'll be doing certain projects, and I'll be uploading that one as well, this one on my GitHub, fast API. So I'll be learning that one from the scratch. So it doesn't take much time. I believe the fast API part will not take that much time. But after finishing the fast API, I'll go with the Django. Let's make some good projects, right? On the front end, let's make use of the React, and on the back end, let's make use of the Django, right? Either on the front end, we can go with the React or the Angular. I'm comfortable with both. I don't have problem with either React or this one Angular. So I can just go with any of them. I don't have any problem. Even Vue is not a problem. So I have done certain two or three basic projects on Vue as well, and I have done many projects on React and Angular. I don't have any problem with the React or the Angular. And on the back end, we will be strictly making use of the Django. If possible, we'll be going with a Flask, but I'm thinking of strictly making use of the Django for now, right? So we'll be doing some projects on the Django, and as well as the this one on the front end side, we'll be going with the either React or the this one Angular. So basically, most of the this one project, so I'll be going with the React itself. So let's go with the React itself on the front end, right? So let's go with the React on the front end and this one Django on the back end. So after finishing this one fast API part, right? So I'll be learning, and I'll just try to implement the same things whatever that I have learned in the fast API. So that one I'll be doing, and later I'll be whatever I have learned, I'll be uploading that one on this one GitHub, on my GitHub, and later we'll be doing the projects, right? Projects on this one, what do you call, full stack projects on React and Django. So we have done around 20 to 25 projects, I think 20 to 25 projects on this one using React, Angular on the front end, and on the back end we have made use of the JavaScript and the Java Spring Boot, right? Nothing but Node.js, Express, Node with Express, and the Spring Boot, right, on the back end. So we have made several full stack projects. Means we have followed certain tutorials, or we have made on our own many projects we have done. Full stack projects, around 20 to 25 full stack projects we have done. So every project is in my GitHub, you can just check. So yeah, this is it. Now from tomorrow I'll not be making any particular 5 or 10 videos a day. From tomorrow we'll just go with three things, right? So three videos per day from tomorrow. One thing is one problem from the Codeforces or the Codechef CP problem, right? Strictly we are going with the dynamic programming now, right? uh, this one currently I'm going with the Codeforces, right, or the Codechef. So we'll be solving one problem from the Codeforces or the Codechef. So currently we are doing this one, we are solving the problems on dynamic programming, right? So one problem from the LeetCode as well, and one video related to the Python, basically related to the system design, right, in the Python. So we'll as I've said, we'll be covering the concepts, this one what do we call, DRY principles, solid principles that is required for the design. And we have already discussed the oops, right? So again, solid principles, oops are fine, DRY is fine, and YAGNI also will be covering, that one also will be doing. And then we have already discussed, or we have already discussed the design patterns, right? So I have made 10 videos, 10 important design patterns, so that we have discussed, and I have uploaded the same thing on my GitHub as well. Whether it may be singleton, whether it may be factory, whether it may be adapter, these patterns we have already discussed, right? Observer, these patterns we have already discussed. Right, so we are done with that part. So we are left with solid principles, DRY, YAGNI, and then we have to solve some of the LLD problems and HLD. Right, HLD I have already solved, so it is not related to any programming language. So HLD, it's the theoretical part and the understanding, this one part, right? Basically, right. So you should have the good understanding. So I have already this one, what I've done, I have already uploaded this one important HLD problems along with the solutions on my GitHub. You can just check on that. So again, I'll not be doing HLD. So LLD problems will be solving, at least 20 to 30 problems will be solving in Python, in Java as well. Both we are doing. Java, I promise that we will not be leaving any freaking topic in Java or the Python, right? So especially prominence to Java. So we'll not be leaving any topic. So we will be covering most of the topics from the scratch, right? Related to the programming language and the data structures along with the design. These three things will not be leaving any important topic. I promise that. So we'll be covering every single topic that is important, right? So along with it, I'll be working on the frameworks or the other stuff that is related to company. That's not personal. That I'll be working, right? So this is fine, man. This is what I'm thinking of. From tomorrow, one problem from the Codeforces, one problem from the this one LeetCode, and one more this thing, one video related to the Python, right? Related to the system design currently. It may be anything, dry, solid. So then after YAG and I, after finishing these three things, let's solve some problems. So every day only one video, so this might take up to the next 3 or 4 months, right? So we'll go slowly from tomorrow. So we are done with most of the important topics. So Python, basic concepts, advanced concepts, oops concepts, then previously we have discussed the design patterns. Now we are done with the data structures part as well, right? So most of the topics we have covered. So we are left with only the design part. We will system design part, nothing but the design part. So we'll be going slowly every day, only one video. From tomorrow we'll be making these three videos personally, and then uh, other things are related to work. I don't want to discuss about that. So other frameworks and other stuff, uh, we'll be working on that. So no worries. For now, this is it, right? So this is going to be the last this one topic in this particular playlist, right? For now, this is it. Thanks for watching, guys.